Hello friends, this video on electricity part 10 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 9 before going ahead with part 10. Let us look at problem number 6. It says, show how you would connect 3 resistors, each of resistance 6 ohms, so that the combination has a resistance of 9 ohms and 4 ohms. So let us first look at the first part. So in the first part, I want the equivalent resistance to be 9 ohms. And how many resistors do we have? We have 3 resistors, each of resistance 6 ohms. Now we are aware of 2 possible combination. One is the 3 resistors connected in series and the other one is the 3 resistors connected in parallel. Now if you connect the 3 resistors of 6 ohms in series, what will be your equivalent resistance? 6 plus 6 plus 6, that is 18 ohms. So that is not our desired resistance, which is 9 ohms. Now if you connect them in parallel, what will you get? We will get 1 by R equivalent is equal to 1 by 6 plus 1 by 6 plus 1 by 6. So this will give R equivalent as 2 ohms. So again, that is not our requirement. We want 9 ohms. So there is one possibility that what we can do is we can put 2 resistors in series and then we can put their combination in parallel with the third resistor. There is another possibility that we take 2 resistors in parallel and then we take that combination in series with the third resistor. So in this case, let us try the first one. Let us suppose if I assume that 2 resistors are in parallel. So if 2 resistors are in parallel, what would be the equivalent resistance? The equivalent resistance will be 1 by 6 plus 1 by 6, that is equal to 2 by 6, or Rp will be equal to 3 ohms. Now we told that 2 resistors are in parallel. Now with these 2 resistors in parallel, the third resistor is now put in series. Now the parallel combination of these 2 resistors gives 3 ohms. So now this 3 ohms, that means instead of these combination, we can say the value is 3 ohms. Now this 3 ohms is in series with 6 ohms. Therefore, R equivalent will be equal to Rp plus 6 ohms, that is 3 plus 6, which is equal to 9 ohms. So that is our desired result. So this would be the desired combination. Now let us look at the second part where we want R equivalent to be equal to 4 ohms. In this case, let us say that 2 resistors are connected in series. That means this is how we first connect 2 resistors of 6 ohms each. So what would be the series equivalent resistance of these two? 6 plus 6 equal to 12 ohms. Now with these 2 resistors in series, let us connect the third one in parallel like this. So what will happen? 1 by R equivalent will be equal to, now these two can be replaced with RS because the equivalent resistance of these two is RS. So this can be written as 1 by RS plus 1 by 6. So this implies 1 by R equivalent is equal to 1 by 12 plus 1 by 6. So this implies R equivalent is equal to 4 ohms, that is the desired resistance. So therefore this would be the desired combination of the resistors. Let us look at problem number 7. It says a hot plate of an electric oven connected to a 220 volt line has 2 resistance coils A and B, each of 24 ohm resistance. Okay, so that means there are 2 resistances A and B, each has resistance 24 ohms. So there is one resistance A, there is another resistance B. Now they may be used separately, they can be used in series, they can be used in parallel. That means you can put these 2 resistances in series, you can put them in parallel, you can use them separately as well. So what are the currents in the 3 cases? So the first case is when you use them separately. So when you use them separately, what is the resistance? The net resistance is 24 ohms because only one of them is used. I mean both of them are used separately. So in one of them, the resistance is 24 ohms, and what is the voltage? Voltage is 220 volts. Therefore, in accordance with Ohm's law, current will be equal to V by R, that is equal to 220 divided by 24, which is equal to 9.166 ampere. So this would be the current when they are used separately. Let us look at the second case where we say that they are connected in series. If they are connected in series, what would be the net resistance? That will be equal to R1 plus R2, that is equal to 24 plus 24, which is equal to 48 ohms. However, voltage in this case will remain the same, that is 220 volts. Therefore, current in this case will become V divided by RS, that is equal to 220 divided by 48, that is equal to 4.58 amperes. Now let us look at the third case where we say that these two are connected in parallel. In this case, what would be the equivalent resistance of the combination? That will be equal to 1 by R1 plus 1 by R2, that is equal to 1 by 24 plus 1 by 24, that is 1 by 12. So we can say that Rp is equal to 12 ohms, voltage is equal to 220 volts. Therefore, current will be equal to V divided by Rp, that is equal to 220 divided by 12, which comes out to be 18.33 amperes. So this would be the current when they are connected in parallel. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.